This is SpaceTime Series 27, Episode 157, for broadcast on the 30th of December 2024. Coming up on SpaceTime, NASA's Parker Solar Probe touches the Sun. New lunar samples show the Moon was still volcanically active just 2.8 billion years ago. And a new map unveiling the uncharted Milky Way galaxy. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Parker Solar Probe has made history, flying closer to the Sun and travelling faster than any other spacecraft ever. The 685-kilogram vehicle swooped down to within 6.1 million kilometres of the Sun, in the process reaching speeds of more than 692 kilometres per hour. And that's fast enough to fly from Washington, D.C. to Tokyo in less than a minute. The probe flew more than 7 times closer to the Sun than any other spacecraft. The extreme close perihelion flyby exposed Parker's heat shield to scorching temperatures exceeding 930 degrees Celsius. Yet the spacecraft's delicate science instrument package protected behind the shield remained at a comfortable 29 degrees C. Following its close encounter with our local star, mission managers at Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, and at the Goddard Space Flight Center in Greenbelt, Maryland, received a beacon transmission from Parker through NASA's Deep Space Communications Center in Canberra, indicating that it had survived the flyby and all spacecraft systems were operating normally. More detailed communications will have to wait until the spacecraft's further away from the Sun, allowing radio transmissions to be sent without being scrambled by the Sun's intense ionizing radiation. Launched back in August 2018 aboard a Delta IV Heavy from Pad 37 at the Cape Canaveral Air Force Base in Florida, Parker's Solar Probe is on a 7-year mission studying the Sun's outer atmosphere, the corona, and the constant stream of charged particles flowing out from the Sun in the solar wind. This is the region where space weather and geomagnetic storms, generated by sunspots, solar flares and coronal mass ejections, are flung out into space and occasionally towards the Earth. Parker is tracing the flow of the energy hitting the solar corona and accelerating the solar wind, determining how energy from the lower solar atmosphere is transferred to and dissipated in the corona and solar wind. It'll also observe the processes that shape the non-equilibrium velocity distributions observed throughout the heliosphere and how processes in the corona affect the properties of the solar wind in the heliosphere. The mission's also studying the structure and dynamics of the plasma and magnetic fields at the sources of the solar wind, how the magnetic field in the solar wind source regions connect to the photosphere below and the heliosphere above, determine if the sources of the solar wind are steady or intermittent, how structures in the corona evolve into the solar wind, explore mechanisms that accelerate and transport energetic particles, and determine the roles of shocks, magnetic reconnection, waves and turbulence in the acceleration of energetic particles. You see, understanding how these processes work will help scientists better forecast geomagnetic storms and also determine their severity earlier. The observations will also help astronomers trying to determine one of the Sun's biggest mysteries, why the corona reaches searingly hot temperatures of well over 1 million degrees Celsius when the Sun's surface, or photosphere, has a temperature of just 6,000 degrees Celsius. To achieve its perihelion close encounter of the Sun, Parker undertook a series of 7 gravity-assist flybys of the planet Venus, the last on November the 6th. This slowed the spacecraft's speed enough to allow it to set course on an intercept with the Sun. The Christmas Eve flyby of the Sun was the first of 3 record-setting close approaches. The next will be on March the 22nd, followed by a third on June the 19th. This report from NASA TV.
Liftoff of the mighty Delta IV Heavy rocket.
In August 2018 in Cape Canaveral, Florida, NASA launched Parker Solar Probe to touch the Sun. After spending a few years spiraling closer to our star, the spacecraft has finally arrived.
It's amazing. Parker Solar Probe is touching the Sun.
This is Noor Rawafi, the project scientist of the mission. He has been waiting for this moment since the beginning of his career.
This is a dream come true. One of the major goals for the Parker Solar Probe mission is to fly through the solar corona, and we are doing that now.
So what does it mean to touch the sun? To answer that, we need to look at the sun's structure. Unlike Earth, the sun doesn't have a solid surface. It's a giant ball of hot plasma that's held together by its own gravity. Solar material flows out from the surface, but around the sun, it's bound by the sun's gravity and magnetic field. This material forms the sun's atmosphere, the corona. Eventually, some of this hot and fast solar material escapes the pull of the sun and gushes out into space as solar wind. The boundary that marks the edge of the sun's atmosphere is known as the Alphane critical surface. We didn't know exactly where this boundary was, but for the first time in history, a spacecraft has crossed it. Parker Solar Probe ventured into the corona, touching solar material still bound to the sun. The wispy corona is too faint to see most of the time, but it's revealed during total solar eclipses. For centuries, we've been studying the sun's atmosphere during eclipses because it's important for understanding how our star influences life in the solar system. But much about the corona remains a mystery.
Two of the most challenging scientific mysteries in astrophysics occur in a region that we call solar corona.
The first mystery is about the temperature. The corona is about 300 times hotter than the photosphere, the visible surface of the sun below. Secondly, there's a constant stream of particles flowing from the sun known as the solar wind. It accelerates up to millions of miles per hour out of the corona, and we don't know how. Solar wind can disrupt our satellites and technology. To better protect them, we need to go where the solar wind starts, in the corona. So heading there has been a key goal of NASA's for a while. We first proposed the idea of sending a spacecraft to the sun in 1958. We didn't have the technology to withstand the journey until the 2000s. Since its launch in 2018, Parker has been heading towards our star. Then, in April 2021, during Parker's 8th orbit around the sun, the spacecraft was around 20 solar radii, or 8 million miles from the sun's surface, when it crossed into the corona.
This is a huge milestone. It took us over 6 decades to come to this point.
As Parker entered the corona, its whisper instrument took images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away at high speeds so that it can't return back to the sun's surface. Inside the corona, the sun's magnetic field becomes much stronger. Solar material is slower and tethered to the sun. Instead of a smooth divide, Parker found that the boundary between these two sides is wrinkly. These bumpy ridges are created from huge flows of plasma traveling out of the corona. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. Before entering the corona, Parker had seen kinks in the solar wind where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed. In 2021, the spacecraft finally tracked switchbacks to one of their origins. As Parker got even closer to the sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the sun. Here we see distinct cells. As heat rises beneath, these convection cells churn and create funnels of magnetic energy above the surface. Scientists found that switchbacks form inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle, though. Exactly how they form is still unknown. Parker will keep looking for clues as it explores our sun, the only star we can study up close. The sun is also the only star known to support life. So understanding it is critical as we search for life beyond our solar system.
That will link directly into the question, are we alone in this universe? And that is one of the biggest questions for humanity to answer.
This is SpaceTime. Still to come, new lunar samples show that the moon was still volcanically active 2.8 billion years ago, and scientists have used computer simulations to provide an accurate map of the uncharted Milky Way galaxy. All that and more still to come on SpaceTime. New data from China's Chang'e 6 sample return mission to the far side of the moon suggests that its landing site was still volcanically active just 2.8 billion years ago, which is far more recently than previously thought. The findings, reported in the journal Nature, claim there was volcanic activity on the basaltic mare in this region over a period of at least 1.4 billion years. Lunar samples returned to Earth by the Apollo, Lunar and Chang'e 5 missions have established that volcanism took place on the near side of the Moon between 4 and 2 billion years ago. However, the lack of samples from the Moon's far side means that it's not been possible until now to confirm the timing of volcanic activity for this region. Earlier this year, the Chang'e 6 mission retrieved samples from the Apollo Basin, located in the northeastern region of the South Pole Atachan Basin, an area believed to have the thinnest crust on the Moon, thereby providing scientists with an opportunity to study far-side volcanism. Researchers analysed fragments of basalt contained in 2 samples of soil or regolith collected by Chang'e 6. Using a process called lead-lead dating, which measures 2 different lead isotopes to determine the age of samples, the authors analysed a total of 108 basaltic fragments. And they found that around 99% of these fragments were around 2.8 billion years old. They also found one fragment containing high alumina basalt, which was around 4.2 billion years in age, implying that volcanism was active on the far side of the Moon for at least 1.4 billion years. However, the majority of the studied basalt fragments did have consistent formation ages of around 2.8 billion years. The authors suggest that this represents the age of the main volcanic episode, at least at the Chang'e 6 landing site, making it a surprisingly young eruption zone and not recognised from observations taken from samples from the lunar near side. Chang'e 6 was Beijing's 6th robotic lunar exploration mission and China's 2nd lunar sample return mission. The flight was launched back in May from the Wenchang Satellite Launch Center on Henan Island. The lander and rover touched down on the lunar far side on June the 1st. The lander's robotic scoop and drill then took samples of the lunar regolith with a total mass of 1,935.3 grams. This was placed in an ascender module mounted on top of the lander. That was then launched back up into lunar orbit, where it docked with the orbiter module and transferred the samples to an atmospheric re-entry module, which returned them to Earth, parachuting down in the Inner Mongolian desert on June the 25th. This is SpaceTime. Still to come, astronomers have developed a new stellar chart providing a more complete map of our Milky Way galaxy. And later in the Science Report, a new study finds that at least 1 in 127 people are on the autism spectrum. All that and more still to come on SpaceTime. Astronomers have developed a new stellar chart providing a more complete map of our Milky Way galaxy. The findings, reported on the pre-press physics website archive.org, suggest that the galaxy was formed in 2 very distinct phases, manifested by different age-chemical abundance relations. The inner disk, located well within the radius of the Sun, formed relatively quickly during the early stages of the galaxy's evolution, probably around 12 billion years ago. Then around 6 to 7 billion years ago, the thinner outer disk began to assemble, rapidly expanding the radial extent of the galaxy and shaping its present structure. Until now, astronomers have sort of roughly determined the size and shape of our Milky Way galaxy by measuring distances to the stars inside it that they can see. The trouble is, that's a bit like trying to see the entire forest when you're stuck in the middle of the trees, and so you're really not getting a full, complete picture. And this discrepancy is due to a fundamental limitation in our observations, originating from our position in the central plane of the Milky Way's disk. See, our location limits the volume of potentially observed stars, depending on how bright they appear. Also, a large proportion of the Milky Way is completely obscured from our view by the gas, dust and stars of the galactic bulge. It means that we cannot see or know what's on the other side of the galaxy, beyond the galactic centre. But by peering into the cosmic dance of stars, the study's lead author Sergei Karpovsky from the Leibniz Institute for Astrophysics in Potsdam, together with colleagues, have unravelled the complex structure of our galaxy. It works like this. Assuming that each of the observed stars that we can see represents a larger population of stars representing the same rough orbit around the galactic centre, the authors have used this to reconstruct the properties of the hidden stars, filling in the gaps, if you will, in the galactic disk, in the process finding some of the secrets of our galaxy's past, present and future. The authors have shown that instead of relying solely on observations of individual stars, the entire orbits of real stars can be used to represent the structure and dynamics of the galaxy as a whole. See, as stars move around the galactic centre, they serve as a tool for mapping regions of the galaxy that are beyond the direct line of sight of telescopes, including areas on the other side of the galaxy. Using a model for the Milky Way's mass distribution and the observed positions and velocities of stars, the authors not only calculated the orbits of stars on the far side of the galaxy, but more importantly, they measured how much mass should be associated with each orbit. Using a novel technique applied to a large sample of stars with spectroscopic parameters from the Apogee survey, which is part of the Sloan Digital All-Sky survey, the authors mapped stellar kinematics across the Milky Way. And this includes the intricate motion of stars in the galactic bar region. And by reconstructing stellar orbits using real Milky Way stars with accurately determined parameters, the authors quantified the galaxy's mass-weighted chemical abundances and age structure. And this approach bypasses the challenges posed by the dense inner regions and interstellar medium extinction, delivering a comprehensive view of stellar populations, including previously unobservable areas on the far side of the galaxy. I mean, it's still only a guess, but it's the most accurate we have so far, and it's based on known physics. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study claims that drinking tea or coffee has a direct association with a lower risk of developing head and neck cancers. The findings reported in the journal Cancer are based on detailed analyses of 14 previous studies that included around 9,500 people with cancer and close to 15,800 people without. The authors found that people who drank more than 4 cups of caffeinated coffee daily had 17% lower odds of having neck and head cancers overall, 30% lower odds of having a mouth cancer, and 22% lower odds of having throat cancer compared to people who didn't drink coffee. And drinking decaf or tea was also linked to lower odds of having these cancers, but in lower percentages compared to those who drank caffeine-filled coffee. A new study has found that an estimated 61.8 million people around the world, that's roughly 1 in every 127 people, are on the autism spectrum. The findings, reported in the Lancet Medical Journal, are based on Australian-led research using 2021 data, the most recent for which accurate information is available. The new figures are substantially higher than previous estimates of around 1 in 271 people, that was based on 2019 data. But the authors say this was mainly due to them changing their approach to exclude studies that probably underestimated the rates of autism. The new study also found that autism spectrum disorder was most common in people under 20, where it ranked within the top 10 causes of non-fatal health burden, emphasising the need for early detection and developmental support for people on the spectrum. Scientists at Melbourne's Monash University have made a huge breakthrough in energy storage technology which could significantly advance the global shift away from fossil fuels. The new discovery, reported in the journal Nature, centres around new thermal energy storage materials which could provide a more sustainable solution to one of the major challenges in renewable energy storage: how to store large amounts of energy inexpensively and sustainably. After all, if you rely on renewable energy sources and the wind doesn't blow and the sun doesn't shine, you need to rely on stored energy. And no matter what the pro-renewables people tell you, there is simply not enough stored energy capacity now or any time in the next 100 years to fill the gap. The newly discovered material integrates 3 modes of energy storage, creating a trimodal system that stores thermal energy with unprecedented efficiency. The material, a mixture of boric and succinic acids, undergoes a transition at around 150 degrees Celsius and can store a record-breaking 600 megajoules per cubic metre of energy, which is almost 2 times higher than many existing materials. This novel trimodal system opens up new possibilities for the Carnot battery, cutting-edge energy storage technology. A Carnot battery converts electrical energy into thermal energy for storage, and then back to electrical energy when it's needed. In this design, the new material acts as the key component for storing the thermal energy, and it can withstand over 1,000 heating and cooling cycles. The key to the material's performance is its ability to store energy through 3 mechanisms simultaneously. First, it stores sensible heat as it warms up. Then, during melting of the mixture, the boric acid undergoes a chemical reaction that further stores energy. And the chemical reaction is highly reversible, allowing this material to be used over and over again without degradation. And that's a major breakthrough in thermochemical TES materials. Importantly, the material is both low cost and environmentally friendly. Boric acid is a flame retardant substance derived from boron ores, and succinic acid, a bio-based chemical, is inexpensive and sustainably resourced. The popular consumer magazine Choice has announced its much-anticipated Shonky Award winners, or should there be losers, for 2024. The Shonkies recognise the worst of the world's products and services from the past year. Tim Mendham from Australian Skeptics says one of the 2024 winners are so-called grounding socks.
Yeah, that's a nice Australianism. I think it's shonky means sort of dodgy.
Another Australianism. Dodgy.
Yeah, same isn't that, yeah. I mean, it's not very good. I mean, it's less than that is promised. It does not work. And normally they deal with a lot of technologies and products that are put forward, even some services at times. With this latest one of the shonky winners was grounding socks. Now,
I've heard of these, yes.
They're supposed to relieve your electric charge. The idea comes from this earthing or grounding movement, which has been around, 30 years or so.
Everywhere.
Well, barefoot on the ground especially, right? You go out on the grass and you rub your sort of bare feet, and that will extract all the surplus electrons out of your body or whatever, all the magnetic impulses, and take it away. You'll ground yourself, and so static will disappear. One of the problems is as soon as you stop doing it, your static will increase, whatever. Anyway, these are socks which you plug in. I don't think you can walk very far, but you plug into a power socket, and it will drain the electrical charge via your feet in a sort of longish socks, Bermuda-style socks. And the Choice people, which are very much science-based, they have a huge laboratory which I've been to, which is fascinating. And a lot of people there working there to actually assess products, everything from soap powders to grounding socks. And what they say is that these things are supposed to offer you faster healing, pain alleviation, anti-aging, and mood elevation. And the evidence these people have put forward is purely anecdotal. Oh, I feel better, whatever. It's purely qualitative and unreliable. Therefore, they're saying there's no evidence for this sort of thing at all, that it's not going to have any lasting effect, if it has any effect at all. And one of the problems they also point out is that the cord that attaches the sock to the power socket keeps breaking. So you wear it twice and it's gone, it's broken off, which is nice to have a bare wire attached to a power socket hanging around. And so apart from the fact that it doesn't work, it also might be dangerous. So they definitely gave this an award. The grounding socks are saying they're really not worth it.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.